feel free to go ahead and share your slides. Professor Temple is a professor of physics at Norfolk State University, where he leads the Quantum Electronics Group and Crystal Physics and Quantum Electronics Laboratory. He also leads the Centers of Research Excellence in Science and Technology, also known as the CREST program, which supports the enhancement of research capabilities of minority-serving institutions through the establishment of centers that effectively integrate education and research. Okay, so you have about 15 minutes for your talk and then 5 minutes for questions.
Okay, thank you. Let me get the pointer straight. As she said, I'm Doyle Temple. I'm the director of the new CREST Center. We think it's flourishing. It's only been open about 7 months, but we think we're more than on track for doing some good things. Just some quick background about NSU, if you don't know about us. Our research is located mainly in the McDermott Center for Applied Research, 128,000 square foot facility. It's mostly laboratories. There's only a few offices. One floor has some offices, and then there are smaller rooms that people put desks in. But so for a school our size, this is actually a very big facility. We're about 85% African American, varies between 4,700 and maybe 5,200 or so undergrads, another 300 to 400 graduate students. We have one PhD program right now in STEM, and that's the PhD in Material Science and Engineering. Several master's programs, and my push for the last few years with everyone on campus is to eventually have a graduate program in quantum science. I'll just mention that at the end. So the CREST Center, we basically want to pick several specific areas where we can take a leadership role. Quantum materials, investigation of new materials, quantum sensing, that's mainly in the area of quantum plasmonics and nano-optics, and then quantum device manufacturing. We have a clean room. So our goals are basically to develop this knowledge and develop the new workforce for the 21st century. This is actually one of the big talking points I have with my own administration, is that if you look at the history of universities and research and just the country, this is the first time that HBCUs can get in on the beginning of something new, because this quantum research is the future, whether people want to acknowledge it or not. This is the future. So one of the things we've managed to do is coordinate another program we have that you may be familiar with, the PRIM program. And our PRIM is a quantum PRIM. It's a collaboration with Fort Lewis College, which is a Native American serving college. It's not a tribal college, but it's Native American serving. We're partnered with the Science and Technology Center Strobe at the University of Colorado. And that one started in 2018. So we had a pretty good running start when CREST came on board last October. And so our leveraging is, CREST is primarily graduate level research with quantum projects. CREST is mainly graduate students, but the undergraduate students that work in CREST are primarily from the PRIM program right now. So the CREST has provided some extra mentors for the PRIM program beside the fact that some of the mentors in the PRIM program are part of CREST already. So we had a pretty good start with students to begin with. And this kind of leveraging is really helpful to build a new program. This is basically the three thrust areas for our research: new materials, new quantum materials, plasmonic sensors, and basic fundamental research on sensing, and then developing and integrating quantum devices and new materials. So I'm the leader for Thrust 1, which is the crystal growth. And this is, I'm not going to go into a lot of detail on the projects. I'm just going to list one or two things that are kind of interesting. And this particular crystal was grown by Takia Robinson, and she's shown in the picture. She grew that when she was a sophomore, and she's given 2 talks last fall, one at the AVS conference and one at the MRS conference on these crystals. And so materials, making your own materials really leads to areas of collaboration. And we also took some crystals down to the magnet lab in Tallahassee last November. And you can see we took a nice little picture above the 45 Tesla magnet. That's me. This is Dr. Salary. He's a physics professor. The first 2 students are graduate students in the CREST. The second 2 students are undergraduate students who are hybrid CREST and PRIM. And this is Dr. Sunil Karna, who's a research associate professor in the group. I just like to always show the students. These actually are not the students in CREST. These are just the students in my group. The students in CREST, I'm working on the first annual report, and I haven't quite gotten a handle on all the students in the other groups yet. So this is just the students in my particular group. So Thrust 2 is mainly Dr. Naganova. She's the leader. And one of the things they're trying to look at is, it's an interesting problem, Bose-Einstein condensation in polaritons. So they haven't seen it, but they're looking for this blue peak, and it has to do, if you see it, then you may be getting this condensation. But that's just one of the projects they're working on. Another one that's actually connected to, that's one of the ways we're going to collaborate between my group and her group, is with the spin angular momentum of light transferring into a material. So this is a very important way to optically measure some of the quantum materials we're growing. The other group is led by Dr. Hak Sung Yoon, and he's also the director of our clean room. We have a class 100-1000 clean room, and I'll mention something more about that in a few minutes. But one of the projects is just development of quantum dot-based sensors. And this picture just always amazes me, that that central dot is only about maybe 100 nanometers across. And today that's actually big. That's a big system in the things people can make these days. But for a school our size, this is a very big deal. Another project they're working on in that group is, we have one of our collaborations is with the local medical school. And so they're fabricating nano probes that they actually use to measure processes in the brain. that's the lab I don't open my eyes when I walk through because I can't quite take the rats, but it's great work. So we're also doing a lot of outreach. That's something we've always done. Most of these students are from the local schools. The elementary school that's about 3 blocks from NSU in one direction, and the high school, which is about 1 block in the other direction. So we have high school students that actually work in the lab. Um, and This is my favorite project, crystal growth. You just melt some, dissolve some sugar in the water, put it on the shelf, leave it there in the classroom for the whole semester, come back, and you have beautiful crystals, and they can put different colors of food color in them and get different colors. It's something the students really like. And so now I just want to say a few things about some of our capabilities. And again, I'm only going to touch on a few things. We actually, we're in discussions now about our building because it's overflowing. Every room is full, basically. Um, so this is just a picture in the clean room. It's 10,000 square foot clean room. The new class is ISO 5 and 6. I'm not a clean room person, so I can't tell you what that means. But these are some of the equipment we have in the clean room, and we have about at least 6 laser labs that are associated with CREST, and 1 or 2 more in the building that we're trying to pull into CREST. This happens to be my lab, and so we have several femtosecond lasers that are tunable from 390 to about 1600 nanometers. Actually, we could get into 2200 if we bought some more optics. But this is just the kind of thing the optics type facilities we have. This is one of the things that we're really excited about. In the last year, we also were successful in 2 instrumentation grants. One of them is a DoD grant where we're going to get an X-ray diffractometer, but the really good part about it is it can go down to 12 degrees Kelvin. Low temperature X-ray, XRD, it's not a fancy thing, but you don't find them they're rare. Big places have them. And so also we're getting a Lowy X-ray machine so that we will be able to do all our crystal processing in-house. The requisitions for this, actually the box for one of these is down on the loading dock. That's the discussion I was mentioning about space. Lots of other, all of the things you need for crystal and sample preparation. Our really exciting new toy is a PPMS, and we were very thankful NSF awarded us this grant. We'll be able to go down to 50 millikelvin at 14 Tesla, which is, we just can't wait to get this thing. And this is part of our own research, but it's also the way that we get collaboration. Collaboration is very, very important, and it helps if you have things that people come to you to want to collaborate on. So this is one of those instruments. When it was announced last fall, we started getting emails from people who saw the announcement on the NSF webpage, and without even doing any work, we suddenly had people that wanted to work with us. So the final thing, the thing that I'm really most interested in this conference is the quantum science education programs. And so I was actually the chair of the physics department at Hampton when the first PhD program at Hampton was getting started. Uh, they had actually gotten it started before I was there, but they kind of asked me to come in and help get it going. And so I have a little bit of experience on the good parts and the bad parts of starting a new program. And so this is kind of our flow chart that we've been following to get to the point where we can start a quantum science graduate program. And we are actually all the way down to the last box. We have more than critical mass in faculty and quality research going on. We have facilities that are excellent and also useful for this type of work. We don't just have a bunch of equipment where most of it is for something else. All of our equipment basically is what you need to do quantum science. Um, we recently have gotten a lot of support from our administration, and I think they're beginning to be very excited about starting a quantum science program. Now, one thing I don't have on this flow chart, or I haven't mentioned, is the fact that we have a DOE cybersecurity center. So we have a very large population of people doing programming. And we've been talking for several years that quantum computing is the wave of the future. So, so there's not a box here that says that because I'm not a quantum computing person. But in this part, this last box of developing the degree program, we're really very excited because I think we're going to have all three tiers of the quantum science program. We will have fundamental research with materials. We'll have devices we can make in class 100, 1000 clean room. And we will potentially have our cybersecurity graduate program. Right now it's a master's program. Transition people into quantum computing. So I think things are looking pretty good for us right now. If we can keep this momentum going, I would definitely say we're flourishing. Right now, we've had a lot of success in the last few years, and I think we can keep it going. So that's it for my talk.
Hey, thank you very much. I want to commend you on offering so many undergrad research opportunities and also high school students. And then also I'm a low temperature experimentalist. I do some device work. You have a very nice infrastructure of instrumentation for that type of work. Especially you said your university has it's one PhD program in
STEM.
In STEM.
We have
STEM,
some,
exactly.
I think, psychology and a few things. But,
excellent. Can you talk a little bit more about the administrative support that's been provided?
Well, we've gotten a space in different places, and they're talking about starting a new graduate program in quantum science, and that involves university dollars. So, and they seem to be very excited about it, and that's the main part. And see, all of this other stuff up at the top, we spend a lot of time getting the base of instrumentation and faculty and everything in position to where it would actually make sense to ask the administration to start a graduate program. And I mean, if you're up here and you're still trying to build a research base and you want to start a program, it's very difficult to talk about getting money from the university to do that. Um, so I'm not sure if I answered your question, but
Yes, you did. Thank you. So, other questions?
Uh, Professor Temple, how's it going? This is Thomas.
oh, hi, Tom.
Yeah, so I had just I would just like for you to just share some advice for those that are at a smaller type institution, so they have higher teaching loads, um, higher administrative responsibilities.
Right.
And not saying that Norfolk State is like that at all, but I know that you've been in certain spaces. So just any advice for people that are trying to do something new, but they have 5 to 6 classes a semester and also are writing their own budget justifications and trying to write proposals and that type of thing. So yeah, can you please share that with the group?
I unfortunately don't have a magic wand, and because I've been in that position, and you just don't sleep. Unfortunately, it's I don't know. I don't have any answer for that other than there's a gear up time where you're really working for yourself and the university, but unfortunately, this is a problem at all small schools. Any small school will have this kind of problem, and you asking that question, you actually reminded me of an answer to the previous question, administrative support. And that was a major thing that they did for faculty at the university is we now have a designation of graduate faculty. So I know at R1 schools to say we only teach 2 courses a semester, they will go 2, but for us to go from 4 to 2 is quite a bit. And so that was a major thing the administration did. There's a process to become graduate faculty and that kind of thing, but I really wish I had some answer for your question that was better than you're just gonna have to work very hard.
No problem at all. Thank you, Professor Temple. I do understand, and I appreciate your honesty there. One other question that I had that's also impressive about what you guys are doing in Norfolk State is you're convincing a lot of different departments and disciplines to work together on this specific goal. And I understand that there's history behind the CREST and the things that Professor Naganoff specifically was doing and all of that with material science. But still, in this new effort, the way that you're able to pivot towards quantum education and quantum science and bringing in things like cybersecurity. So could you just talk a little bit about maybe how that happened? Any advice for people that are in a similar situation in their own environment?
I've been talking with computer science for 4 or 5 years, so it's not like it's a long conversation you have with people, especially when different types of funding solicitations come out. It's always better to have a critical mass of good faculty when you go after large grants. And I think everybody kind of realizes that. And my saying is, it sounds silly, but a piece of the pie is better than no pie. And so that's kind of how I approach things. It's, we're better off together.
Okay, thank you very much. For the sake of time, we should move on to the next speaker, but please continue the conversation in the chat. That would be great.
See, I have to stop sharing. There we go.
Okay, thank you very much. So let's thank Professor Temple